So the meninges. All right, we've talked about these already in the spinal cord. And remember, they're just connective tissue membranes that are going to be enveloping the spinal cord in the first part of the talk when we did that in chapter 13. But of course, now we're looking at how they function around the brain. And for the most part, they're continuous at the spinal cord, at the foramen magnum, into the brain. But we'll see there are some distinct differences. So they're meant to isolate the nervous tissue of the brain from the surrounding tissues. And just like in the spinal cord, we'll see the tough mother, the outer layer, the dura mater, the spidery layer that called the arachnoid mater, and then the inner affectionate layer called the pia mater. And so as we already said, they're there for integrity and protection, but they're also going to provide pathways for blood vessels to follow. So meninges, remember, dura mater. In the cranial cavity, though, it actually splits into two layers. There's the cranial layer that is really closely associated with the cranial bones. Now, it doesn't actually attach to them, except in very limited locations. But you should understand that this layer means that there is no epidural space, the cranial dura mater. So again, they'll split into two layers, but we'll talk about those two layers and we'll see those in just a sec. So because of the way they are very closely associated with the cranium, there is no epidural space. Right? So the layers, though, will actually separate in certain regions of the body, and we'll discuss those, of course, in more detail. So there you see the meninges, the dura mater, and the lighter covering of the arachnoid mater. Now, as I mentioned, since there are two layers, the innermost layer can fold and extend between parts of the brain. And the part when it extends, where the longitudinal fissure is in between the two cerebral hemispheres, is called the falx cerebri. Then we have the inner layer that goes in between the region, the delineation between the cerebellum and the cerebrum, and it's given the rather Roman-sounding name of tentorium cerebelli. And then finally we have a small opening gap in between the hemispheres of the cerebellum, and so that is called the falx cerebelli. And we can see them represented here in these shots. Really good shots. And certainly you'll be responsible for the anatomical designations for the lab quizzes. So the arachnoid and pia mater are just like they are in the spinal cord. The arachnoid mater has the subarachnoid space where all the cerebrospinal fluid flows, and you have a space between it and the dura that lies above it called the subdural space. And this can be a space of very important occurrences called subdural hematomas, right? They're associated with concussions, which is all the rage in the sports world right now, is how to deal with concussions properly and try to minimize their appearances. The pia mater, which is pretty much very closely attached to the surface of the brain, and you usually can't see it unless you prepare it very specifically without a microscope. So here we see the designations. Here's the skull, of course, the two layers of the dura mater, where we see one that's going into the longitudinal fissure. This will form the falx cerebri, but the other layer stays near in association with the bone of the skull. Then the arachnoid mater with its arachnoid spidery-like features coming down. This is where the cerebral spinal fluid will flow. And then finally the pia mater that is directly attached to the surface of the brain. Now, when you get inflammation in the meninges, of course, we can get a condition called meningitis. And it's caused by either bacterial or viral invasion of the central nervous system, and what it will affect, of course, are the layers of the meninges, most typically the pia and arachnoid. Now, if you have a choice of getting one, get the viral form, because the bacterial form is much more deadly, much more difficult to deal with. The brain has a lot of problems dealing with any infections inside it because it doesn't have much of an immune system response to invaders One, it is hard for invaders to get into the brain because of the blood-brain barrier, but two, there's not much of an immune system for those invaders that have to worry about. The meningitis then will cause swelling of these meninges, which can lead to a swelling of the ventricles and eventually potential damage to structures of the brain. There is also a fungal form of meningitis, which is very serious, very, very serious. So symptoms, the classic symptom is the stiff neck. One of the tests is to take your neck, your chin, and place it on your chest. If you can do that, then probably don't have meningitis. If you have a lot of pain and suffering from trying to attempt it, then meningitis is certainly a consideration, right? Intense headaches will develop, and if you don't take care of it, it can be very rapid acting on your body. What is accomplished is called a lumbar puncture. They will sample the cerebrospinal fluid in the spinal cord and will look at the subarachnoid space. We'll put a needle in through that, as you might imagine, extremely painful and agonizing. Cerebrospinal fluid should be pretty clear if it's normal, but if there is evidence of meningitis, it will be clouded.